In this very exciting episode of FUM0152 machining, we are going to drill a hole in the quill holder, and this hole will be for this piece. It will go perpendicularly through there, and it must be quite precisely placed, the hole. It must be straight and it must be perpendicular, and placing is critical because we have to mesh the gear with the rack. Well, there is a lot of opportunities for mistakes here. So much of this is to minimize the opportunities. I have invented some ways to do this. Let's see. So, the first and the hardest thing actually is to set up the mill. Let's do that now. First of all, this milling head is pointing to the wrong direction. I need to turn it around a little bit. Let's unlock it. Okay, so now it's turned around and roughly in the correct position. It might be that we need to change that. Okay, next step. The surface on this one, this is the surface for reference in this side. This is what we have been using all the time for referencing. So, the next step is to clamp it somewhere, and now I need to figure out where. I'm going to use this. This is a 25mm drill. I need to see that I have enough room to install it here. So that's the longest I want to go. Just put the drill there temporarily to see about the place. I think it is. This might become tight. Okay, that's about the correct place, but let's see now if I can get this drill out from there. Yes, I can. Very good. Another thing we are going to use here is this boring head. And now I need to check that we have enough room for it to run here. We'll see about this. There might become a problem. I need to rise that one, and better to rise it now than later. This is good. This is not... let me do some thinking outside the camera. This is not going to work. So, here is what I ended up with. First of all, there are two parallels under here. They are not that way, but they are this way. So they don't come out from the bottom to disturb things. I know that the parallels are not supposed to be really accurate on their thickness. But I measured these, and these are actually. Good. And then I have set up these blocks here, two of them, which are now tight. I dialed this in, it's perpendicular, and these are just to prevent when I'm drilling there will be pushing forces, which will push this, try to push this thing towards that direction, so therefore I have these things under here. There will be some, drilling is quite violent operation, so therefore it's not you need to attach this thing securely into the table. Now the next thing is to determine the Z. How in earth can I set the Z so that this one is meshing correctly with the gear rack here under? Well, that's I actually came into a solution which doesn't require any measuring. And let's see how it is. First of all, we have I will be using this ER40 collet. Well, and now comes the funny part. I will use this. I will put this one into the spindle, and there you go. You should be able to try out your meshing. Really try it out, because after that, when we have set the Z, it should be. Oh yeah. The spaces are really tight this time here. Okay. Oh yeah, now it's there. Well, now we have it there. And yeah, free gear. So now what I'm going to do is to try it out like this, wiggling it, and when I get minimum play, and there still is some play, so then we are quite near. That would be nice, but is it well, it meshes quite good. You can actually, I think that is the correct height. Now let's lock it and see if it still works. Yes, it does. Next will be the Y direction. It should be somewhere, somewhere, yeah. Not in the exact center, but some maybe 10 millimeters back from that. Okay, so now I will do that, but I will do that off the camera. Yeah, it's just a simple thing to do. Yeah. Well, this is now progressing. After some, I have been training myself for boring. It has been a journey. For the first, this Wallhauter. I think it might be my fault, but it's also because somebody did something for it. They had changed the adapter for this SK30, the taper attachment for the mill. It was not properly seated and it was a little bit wonky there, and now it is properly seated. I had to do some hard turning in the lathe to get this correct. And now the adapter is seating as it should. And now it's rigged. It was not rigged, you could hammer it to other side quite easily. Well, that's not very good. Okay, that was first. The second was that I noticed that I was using too long boring bar, which cost me some harmonics. And that ended up in very bad surface finish. Okay, the next step was to notice that, okay, I have the wrong type of insert here, because I cannot take something like very deep cuts. I have to stay within half millimeter from the diameter. For this reason I found out the correct combination. Now I have here, I had one, I had forgot, but I had one boring bar which is solid carbide. And then putting the correct insert into there, and then we have a mirror finish. Huh. Well, it makes all the difference. And now I noticed also this is not it's an interrupted cut. So therefore this causes trouble as well. So and now when I do a pass in and another pass out, it leaves how would I say, it's very accurate, so that I can bore this hole down to 100th of a millimeter accuracy. Earlier that simply wasn't possible. Okay, so I have developed some methods here specifically to this mill. For the first, the stops here, there are two stops, one to this, so it stops automatically the travel of the table. It stops a few 1 millimeter maybe before the bottom, and I do the rest using the hand wheel down to 100th of a millimeter accuracy. And then I go back and it just stops when it's pulling itself out to a suitable place. Oh yeah, that's just convenience. You could, but I can use the power feed, which also contributes to the surface finish of this one. Oh yeah, that's has been really learning, and now I'm confident I can make this hole to the proper size and proper depth. And the last step here will be, it's specific to this Wallhauter. Of course, the bottom of this, it's a hole, and then it enlarges, and then you put the bearing into that hole. I will show you a photo about this. But the bottom is, at the moment, it's not straight, it's jagged. Because you come in half millimeter, there are half millimeters ridges there. I will wipe them off using the planing functionality of this boring head. And that's something you cannot do with a cheap Chinese thing, really. And furthermore, the adjustment is really nice in this one. You can adjust it in very easily in 100th of a millimeter steps from diameter. And this is, my measuring accuracy is also pushed down to the limit, but I'm quite confident I can do that. We still have some 5 millimeters to go, so I will show that one in another camera. So let's mill. is ready so far. And yeah, well, what can I say? It works. Well, and now we shall put it together. So, Loctite. And this has been sterilized, as is this. So I will put some glue into it. And then I just put it there. Oh yeah, ooh. Oh. This thing, it goes into from the back side. We have this nice nut, which it doesn't need to be very tight, just like that, and then we put this one on top of that, like that, and this one actually tightens the whole thing. There you are. Let's put some oil here. And you can still use your finger, yeah. This part on top of that, actually how you put this together is that you slide it from this way, because otherwise it won't go there, and then you just bolt it there and it operates really well. There will be a brake, and it's in this part, so therefore I don't bolt it there just yet. We need to slit this here. Here, a slit goes beyond the half of this, and then we need to mill lightening here, so that it bends a little bit easier, because this is quite thick, really. If I just leave it as it is, it might work, but it might be really stiff. We soon get rid of this excuse for a tailstock. Yeah, finally. Okay, so let's start slitting this cap there and making the tinning. The new tailstock is now ready. It can be used. Well, there are two things I want still to do for that one. First, the brake handle, that's one thing. Well, the brake works really nicely. not a lot of force is required and it will stall really. Good. Another thing is to put a knob at the tail end of the tailstock, the quill end. So you can push it around that's one. It's like something like fast move. Yeah, I'm satisfied. And yeah, what's next? Oh, okay, let's see. But that we will see in the next episode of Finno Machining. Till then, bye!